You are 30 minutes into a job interview on an automated screening platform. Your webcam is on, your lighting is perfect, and you have delivered a series of clear, technical answers. You feel prepared. But the interviewer staring right back at you is a digital avatar. Suddenly, the system pivots. In a calm, synthetic voice, it asks you to explain the specific database architecture you used to resolve a server latency issue during a project from years ago. Faced with a highly specific, multi-layered problem, your biology takes over. You do exactly what any intelligent person does when they need to retrieve complex information. You instinctively break eye contact. You take a deep breath, and you just sit in silence to organize your thoughts. That completely normal, rational human reflex is the exact trigger for an algorithmic failure. As you quietly scan your memory, the algorithm begins a countdown. The system detects the silence in your room, and it waits exactly 3 rigid seconds. 3, 2, 1, 0. The microphone cuts your audio feed. Before you can begin your response, the AI logs your answer as finished and assumes you have nothing left to say. The screen refreshes and the avatar moves to the next question. You are permanently locked out of your own response, with absolutely no human on the other side to pause the test or to acknowledge that you were simply thinking. This is the silence trap. It is a mechanical hurdle in automated hiring that eliminates qualified candidates who do not understand how the software manages the conversation. Human interviewers use silence as a social cue. When you pause, a hiring manager sees you looking at your notes or furrowing your brow. They recognize this as deep, careful thought, and their social instinct is to grant you the patience to formulate a response. An automated platform possesses no social awareness. It does not read your facial expressions for validation or feel the awkwardness of a quiet room. It evaluates purely on incoming data streams. These platforms manage the conversation using voice activity detection. The software monitors your microphone for an active audio waveform. If it hears sound, it continues recording. If it detects absolute silence, it closes the file and moves on. The VAD operates on a binary rule. Audio input indicates you are answering. Silence indicates you are finished. To an algorithmic detection system, a thoughtful human pause is indistinguishable from an empty chair. While the microphone is listening for sound, a secondary layer of the system is analyzing the content of your speech. The AI is transcribing your spoken words into text in real time. The system uses this transcript for chain-of-thought processing, mapping your reasoning by identifying syntactical joints, words like because and therefore. When you go silent, the logic sequence stops. You stop feeding the algorithm the data needed to reach a solution. The AI cannot evaluate reasoning it cannot map. Without a completed chain of transcription, the grading rubric registers a missing link in your logic, leading to a lower score. Going silent creates a total data blackout. From the perspective of the grading algorithm, your logic sequence has ended before it could be verified. To bypass the VAD trigger, you have to use a strategy called the speak-to-pause method. The objective is to manually keep the microphone active. Instead of thinking quietly, you must narrate your internal process out loud. When you face a difficult prompt, you claim your thinking time using specific vocalized bridging phrases. You say, "Let me think for a second to pull up the right project," or "That is a complex scenario, let me structure my thoughts." Stating these phrases aloud keeps the audio waveform active. It provides the necessary seconds to retrieve a memory without triggering the system to cut your recording. This keeps the system in a recording state, preventing the automated cutoff while giving your brain the window it needs to work. Beyond maintaining the audio feed, stating your intent out loud provides the system with a specific type of linguistic evidence that improves your evaluation. When the AI transcribes a phrase like, "Let me structure my thoughts," it fills the logic gap with a purposeful transition. This allows the algorithm to maintain a continuous connection to your answer, marking it as a successful sequence. This is the shift required for modern hiring. You are no longer just answering questions for a person. You are organizing a data stream for a machine. To navigate these platforms, you have to adapt your human instincts to match the binary logic of the software. Narrate your internal steps, provide the system with its logical joints,